Okay, so here's an example taken directly from your homework. Noise levels at 4 volcanoes were measured in decibels, yielding the data 152, 157, 157, 158. And then we are going to construct a 90% confidence interval for the mean noise level at such locations. Assume the population is approximately normal. So n is equal to 4. Our sample size is equal to 4 because there's only 4 volcanoes. This is a really small sample size. It's less than 30, right? So that's your key to use this t distribution. If you have a really small sample size, you use the t distribution. So in Hawks, it's not going to always tell you to use the t. You have to know when to use it. And that's one key way to know is, what's my sample size? Is it smaller than 30? Yes. Use the t. Okay. So they're also not giving us all the other information we need, right? We have to calculate the error, which is t star times s divided by the square root of n. Well, t star we can figure out in a moment by looking at the t table, but we also need the sample standard deviation. So you're going to have to break out Excel for problems like this. So you should be able to copy it directly from your homework. I got to type it in here. And we need the sample standard deviation. So that's stdev.s. There we go. And I'm going to maybe do 4 decimal places for now, so we don't have rounding error at the end. So 2.7080. So our sample standard deviation is 2.7080. Okay. So we have our S, we have our N, we got to figure out our T. So 90% confidence interval, if we look back at this chart, 90% again corresponds to a two-tail area of 0.1. And remember, we also need the degrees of freedom. So let me figure that out first. Degrees of freedom, call it df. That's your sample size, which in this case is 4, and then you subtract 1. So our degrees of freedom is going to be 3, and we have a two-tail area of 0.1. So popping over to the t table. Let me erase all this stuff. So once again, you can pick either the area for the one tail or two tails. Just pick one, the one that you're looking up. You don't want to look up both. I mean, you can, but you'll get the same thing. So we had a two-tail area of 0.1. So that's right here. And then 3 degrees of freedom. The intersection looks like it'll be right here. 2.353. So that is going to be my t value. My t star is 2.353. Okay. So I'm just realizing I kind of went out of order from the directions here. You can follow this order. Basically, I did 2 and 3 first. And I forgot about number 1. Because we will need the sample mean. We need the sample mean to actually figure out the interval. So I'm going to pop back over to Excel and find our sample mean. So remember, the mean is not a formula in Excel. You have to use average. And just take the average of those 4, and we get 156. So my x bar is 156. That's the sample mean. Okay, now we have all the pieces that we need to calculate this interval. I'm just going to keep going this way. All right, so E is equal to our T star, which was 2.353 times S, which was 2.7080 divided by the square root of our sample size, which is the square root of 4. And I went ahead and calculated this. So you pop this into your calculator or into Desmos, and you should get 3.186. All right, so we found our error. Once you find your error, you can actually find the confidence interval. And to do that, remember, we have the lower bound, which is your sample mean minus the error. So we'll have 156 minus 3.186. And then our upper bound, x bar plus the error. That's 156 plus 3.186. So calculating those values, you should get 152.814 as your lower bound, and then 159.186 as your upper bound. And that is our confidence interval. So again, the process is essentially the same. You need the sample mean, you got to calculate the error, and then you add and subtract the error to the mean to figure out the interval. What is different is just using the t-table to figure out your t-star value. And to do that, you need to know the confidence interval, or the confidence level, which will tell you the area between either in the two tails or the area in the one tail, depending on which one you want to check out. And then you need the degrees of freedom, which is 1 minus the sample size. All right, we have one more problem to do. And this is a little bit different from building a confidence interval. We're not going to be building a confidence interval. We're going to be working backwards. We're going to, given a bunch of information, can we figure out the sample size the appropriate sample size we need to estimate a population mean? So, because once again, we've talked about this in the last section, but the more samples, the better. But you don't always need 100,000 samples. It really depends on the information you have, the data that you have, and we can use this handy formula to help us figure that out. How big should my sample size be for a given confidence interval? So let's read. A fast food restaurant executive wishes to know how many fast food meals teenagers eat each week. They want to construct an 85% confidence interval with an error of no more than 0.6. And we will need that. An error of no more than 0.06. A consultant has informed them that a previous study found the mean to be 4.9 fast food meals per week and found the standard deviation to be 0.9. What is the minimum sample size required to create the specified confidence interval? Round your answer up to the next integer. All right, and we just got to plug the values we need into this formula. So n is equal to z star. We have to get that from that little chart of critical z values. So we're doing an 85% confidence interval. So let me scroll. Oh, you know what? I have that on a different sheet. Here we go. Here are my z values. So 90, were we doing 95%? 85%. 85%. My z value is going to be 1.44. Okay, so I'm going to pop back over. So our z is going to be, or z star is 1.44. We just looked that up in that little table of values. Times the sigma, the population standard deviation, 0.9. Divide that by E, which that's what they're giving us here, an error of no more than 0.06. So our error is 0.06. And then we square that value. So once you work that out, I'll go ahead and do it in steps. I get 21.6 on the inside, and then square that, you get 466.56. And for these problems, Alex is gonna want you, Hawks, not Alex. Hawks is gonna want you to round to the nearest whole number. Because when we're working with samples, we don't have half a sample. You have one sample or two samples, so on and so forth. So since this is a 5, we are going to round up to 467. So we just worked backwards and figured out how big of a sample size we need to construct an 85% confidence interval with an error no bigger than 0.06. Okay, so that is it for this week. Confidence intervals essentially, and then kind of working backwards to figure out the sample size needed for specific confidence intervals and errors. But just what I want to reiterate on Hawks is you really have to read the problems for these. And if you have a small sample, then you need to use the t distribution. So if n is less than 30 and also your sigma is unknown, that means they're not giving you information on the population standard deviation. They're probably giving you the sample standard deviation, or in our case, we had to calculate it. But that's when we use this t distribution, the t table. However, if we got a big old sample size and we know the population standard deviation, that's when we use the normal distribution, which is our z's. The z tables, which we're not using the z tables right now because we're just giving you the proper z value. Sorry, that's like slanted, I know. That's just how I was writing on my pad. So anyway, read the problems, figure out if you need to use the z or the t, and then proceed from there. So I know I only did a couple examples. If you want me to do a few more, shoot me an email and let me know. If you want me to, post up another video or two on some examples. Have a great week.